When performed correctly, laser-based varicose vein ablation is one of the most effective and least invasive methods of resolving inefficient lower limb vein trunks. The procedure's effectiveness depends on the type of laser, the energy it generates, and how this energy is transferred to the vein, which is clearly interconnected with the quality and type of the optical fiber used. The key is the shape and width of the beam emitted by the glass tip of the optical fiber onto the vein wall. The past few years have seen a major revolution in the way light is emitted through the fiber optic tip in endovascular procedures. Starting with bare fiber, radial and dual radial fibers, and ending with the most modern technology available, infinity ring or multi-ring fibers. What do these changes bring, and why are they so important? To begin with, let's recall the concept of power density. Power density is the power of the light beam per unit area of the vein wall, expressed as W/M2. The beam emitted straight ahead by the bare fiber had a spot effect. It heated the tissue in one small place so that the temperature gradient increased rapidly, reaching several hundred degrees centigrade, causing carbonization, damage, and even rupture of the vein wall. Moreover, the section of the vein at the cinefemoral ostium remained partially open. With this type of fiber, it was necessary to maintain a safe distance from the ostium due to the risk of energy emission into the deep venous system. Leaving a partially open section of the vein in such a critical location increased the risk of recurrence. Radial fiber optics brought the first breakthrough. Light emitted laterally at a maximum forward angle of 60 degrees could act closer to the ostium and directly on the vein wall. As a result, the effectiveness and safety of the treatments increased significantly. The distribution of light energy shaped as one or two narrow rings increased the surface area of the beam and thus reduced the power density. The number of complications was reduced because of a milder temperature spike. However, the temperature was still high enough to cause carbonization of the tissue. What was the result? A tissue-laden fiber optic tip could not properly emit all the energy from the generator, which led to ineffective closure of the vein. The real revolution was yet to come. The designers went a step further and created an optical fiber that is not single, not double, but multi-ring or infinity ring, with the tip emitting light in the shape of a spiral. The new design generates a cylindrical beam of light as long as 4 millimeters. Such a significant increase in energy area emission and simultaneous reduction in power density provides a smoother temperature gradient in the tissue and eliminates the carbonization effect. This state-of-the-art optical fiber operates at a low peak temperature and, at the same time, effectively and safely closes the vein due to its very precise energy deposition in the target area. The energy emission is uniform. The optical fiber does not adhere to tissues and easily passes through the vein, as seen in tests. The light is emitted only laterally and rearward. As a result, treatments can be started almost right at the cinefemoral ostium. All of these features significantly increase the procedure's effectiveness and patient safety during the treatment and reduce side effects such as pain and discoloration. Combining the infinite ring optical fiber with the neoV 1940 NM laser allows for more reliable and safer operation. This wavelength stops at the walls of the vein without passing through it, which significantly improves the safety of the procedure, especially for veins located just under the skin and running close to the nerves.